Okay, welcome guys. So we have this question here where we have to prove that tan alpha minus beta is equals to tan alpha minus tan beta divided by 1 plus tan alpha tan beta here. So here we're just going to show that the left hand side here is equal to the right hand side after we simplify it. So then we start with the left hand side. So here we have tan alpha minus beta like this. Then we know to say that tan is simply made of dividing the sine function and the cosine function. So meaning that this here is simply equal to sine alpha minus beta divided by cos alpha minus beta like this here. So then here, this is an identity that we have here on the numerator here, and this is equally an identity that we have there. So we get the identities and we substitute them there. So we know that sine A plus or minus B is simply equal to sine A cos B plus or minus cos B sine A like this here. Then for cos A plus B here, we simply have cos A cos B minus plus here sine A and sine B like this here. So with respect to the expression that we have here, we're going to substitute with an identity that works for this expression here. So meaning that there, where there's sine alpha minus beta here, we're going to pick an identity here, which is sine alpha cos beta minus cos alpha sine beta like this here, divided by, for the cosine function, so here you notice that we have plus or minus down there. So we have a plus there and we have a minus here. Then on the identities here on the right hand side, we have a plus on top and we have a minus there. So meaning that if in the brackets here we're adding, we pick an identity with a negative symbol this side. Then if this side here we're subtracting, we pick an identity with a positive symbol there. Okay, so now here for cos alpha minus beta here, the identity that we're going to substitute there is going to be cos alpha cos beta plus sine alpha sine beta like this here. So now here, if we say let's divide throughout each term by cos alpha cos beta here, so I just say dividing throughout, say dividing throughout each term by cos alpha cos beta like this here. So let me just scroll down a bit. So then this here is going to give us sine alpha cos beta divided by cos alpha cos beta like this minus cos alpha sine beta divided by cos alpha cos beta like this. Then everything here we divide with cos alpha cos beta by the same thing, which is cos alpha cos beta plus sine alpha sine beta divided by cos alpha cos beta like this here. So let's just scroll down a bit. Now here you notice that cos beta they are going to cancel out, cos alpha going to cancel out there. Then here this will just give us 1 there. So meaning that this here we're simply going to have sine alpha divided by cos alpha minus sine beta divided by cos beta here. Then everything we have divided by 1 plus sine alpha cos alpha. We close and we have sine beta cos beta like this here. So now we know that when you divide a sine function by a cosine function, you get a tangent function. So meaning that everywhere we're dividing a sine function by a cosine function, we're going to replace it with a tangent function. So meaning that here we have tan alpha minus sine or minus tan, sorry, beta divided by 1 plus tan alpha tan beta like this here. So if you look at this, this is equal to the right hand side there. So therefore we've proved this identity there. Okay, let's go to the next one.